Hello everyone and welcome to Module 5 where we will be building our first basic IoT system. Earlier on we had discussed on the different components that make up an IoT. We mentioned that the first one is a sensor or the device. Then we talked about the platform where we give the instructions on what this IoT system should do. Then we discussed on communication and the application where you get to view the results and analyze and download and do many things. In this exercise where we'll be building a basic IoT system, we'll only focus on the first two. So we'll be looking at the sensor or a device which is connected to a microcontroller, and we'll also be covering the platform where we'll be looking at the scripts or the instructions that we give the IoT system on what to do. So what do we need? We need a temperature sensor, that is the DS18B20 temperature sensor. We need the LoP4 microcontroller. We need a computer that has Visual Studio Code and PyMaker installed. If you have a problem with this, you can visit the previous module, that is module 4, and see how we were able to set this. And we also need the micro USB cable. So I'll go ahead and demonstrate to you what we have. So here with me, I have the microcontroller as a start. If you followed module 4, you're already familiar with this. So I have the PyCom LoP4 microcontroller. I have the USB cable here with a micro USB on one end and the type A on the other end. This is where we connect to the computer, and the other end, the micro USB, is where we connect to the microcontroller using the micro USB port. And here we have a temperature sensor, that is the DS18B20. Of course, a computer, you must be having a computer right now that has Visual Studio Code installed together with PyMaker. So the purpose of the micro USB cable is, of course, to provide power, because we're doing this while connecting the microcontroller to the computer. So the purpose of the micro USB cable is to provide power. But in the event that you're deploying your IoT system out in the field, then you may need a LiPo battery. A LiPo battery is connected as indicated. I'll show you here. So here we have a LiPo battery, and this is a port that connects to the micro USB, the microcontroller. So the way it works is that this port has to fit into this section of the, if you can see clearly, it connects to this white part. So in the microcontroller, there is a part where you connect the power. So the way it usually works is that we come and connect it here. I will connect it and you'll have a look, and press it until it connects. This should be able to power. Probably this one is not going on right now because it's out of charge. I need to recharge it, but that's how it works. So that's how you connect. So when you're deploying your IoT system out in the field, this is a source of power. But because we are in the office right now, we'll be using the cable to provide power. Okay, I'm going to disconnect this and put it aside. Now let's have a look at the temperature sensor. The temperature sensor comes with 3 wires, as you can see. We have the black, which can be in some cases blue and in some cases green, as you will see. So when it comes with different colors, don't be afraid of anything. It's okay. But the yellow and the red are standard. They always come as yellow and red. So what happens here is that the blue or the black or the green in this case is a ground, is for ground. That's we connect it to the GND port in the microcontroller. The yellow is for data. This is where measurements are taken through. This is the one that communicates the information from the sensor to the microcontroller. You may connect it to P10 or any port, but of course you have to define in the script where you connect it. Then we have the red. This one goes to the 3.3 volt pin because this is the one that supplies power. Next, we will demonstrate how to connect. So to build our basic IoT system, this is how we're going to connect the temperature sensor to the microcontroller. The black or the blue, or in other words the green, depending on your cable, connects to the GND, like I mentioned in the previous slide. Then the yellow goes to a pin of your choice. In this case, I've selected P10. And the red goes to the 3.3 volt pin. This is where it's going to extract its power, and this is connected to the GND, or in other words, the ground. and the data cable goes to the pin 10. You can choose, like I mentioned, you can choose which pin you want to connect it, provided you mention these in the script, like I'll demonstrate later. So let's go ahead and connect it. So here we have the temperature sensor. I mentioned that the G&D may come in blue, like in my case. It may come in black, or it may come in green. The power cable is red and the data cable is yellow. So I'm going to connect them directly. If you refer to the previous slide, I mentioned that the power cable is going to connect to the power pin, which is here, so I'll insert it. The blue one, or the green or the black, will go to the G&D. I'll insert it. Make sure it connects firmly inside. It's connected. And the yellow, which is the data cable, for my case, I'm going to insert it to pin 10. So go ahead and insert it to pin 10. So we have it connected. I don't know if this is clear. Yes. So we have the blue going to the G&D, or the black or the green, depending on your temperature sensor. The red goes to the 3.3 volt, and the yellow goes to the pin 10. If you've managed that successfully, and you've ensured that the cables are going deep into the pins, then we will connect the micro USB, which goes to this port. Now that we've made that connection, we will now connect the other end of the USB cable to our computer. So we have it already connected. As usual, it's blinking blue, it's flashing blue, the LED at the top here. And we have the green on this side, that is a USB light, and the LED light is orange, that is on the expansion board. If we have gotten to that level, then the next step would be now to start the Visual Studio Code. So we have the Visual Studio Code there. Now let's navigate. Let me take you back there. It says we navigate now to the folder that contains the files, the scripts. So I will navigate to the folder that contains the scripts that we want to upload and run. So go to File, Open Folder, and I'll navigate to the folder where, in my case, I have it here, and I'll go to Module 5, and I'll select the folder and select it. Let's maximize this. Once again, if you remember, I mentioned that if you have an issue with regards to the COM port, like in my case here, the COM port, it says it's trying to connect to COM9, but then it failed, so which means the microcontroller is connected to a different port. Very quickly, I'll demonstrate how to fix that once again. Otherwise, if you still have a problem, I refer you to Module 4 where we demonstrated in detail. So for my case, I'll open the device manager very quickly to sort out that. My microcontroller is connected to COM port, COM5. So I'll go ahead and select and edit 5 and save it. Once again, I'll connect it, and we are connected. So the next step will be to upload the scripts. So I'll upload all the scripts that are within this folder. At the bottom here, I will go and say upload. And the first thing it will do is it will remove the previous files that were installed. And the next step, it will be uploading the scripts now. So of course, if there were previous scripts, if there were scripts within the microcontroller from a previous exercise, the first step will be to delete them, or rather remove them, before uploading the new ones. So I've successfully uploaded the scripts that we will use for temperature measurements. Let's go back to the slide. So I've managed to go to the folder, the DS18B20 temperature sensor. Of course, you won't follow this path. Of course, you will need to navigate to where you've saved your file. Now let's go ahead and select the demo file. Here we have the demo, as you can see. I'll select it. It will open. Once it has opened, I will go ahead and run it. So at the bottom, go and click on Run. What do you observe? For my case, it measured temperature once, and it said, so the temperature measurements, as you can see at the bottom there, is 22.3, and after that it stopped. Were you able to achieve that? If you're not able to get that, then repeat the process once again. So go ahead and play the video once again and follow each step carefully. Let me repeat running. I will run once again, and it will take measurements. So what you're noticing from this demonstration is that the script is able to instruct the microcontroller to take measurements from the temperature sensor once. Hope we're together up to that level. Let's go back to the slide. Now let's go to the second script, that is main_new. So I'm going to minimize this, and I'm going to click on main_new. So I'll run this file. Remember, these are separate file from the previous one, so make sure you click on it and it should open before running. Now I'm going to run this. What do you observe? This time round, it's taking measurements continuously. So the script is continuous, so it's been written in such a way that it's going to take measurements continuously. If you're not getting this, kindly go back a few steps, follow the video once again, follow this time carefully. You should be able to get this. Let's go back to the slide. So we followed all the steps correctly, and now we are able to take measurements continuously. In the first demonstration, we were only taking measurement once, then it stops, but right now it's taking measurements continuously. Now, finally, let's go ahead and hold the sensor. So what I'm going to do, I'm going to demonstrate to you that. So we have the temperature sensor here that is still running. Remember, it's still running in the script. It's running and it's continuous. So I'm going to get hold of the sensor at the tip here, and I'm going to hold it firmly. Let me hold it with my left hand. I'll go back to the script. If I hold it continuously for some time, what happens? You notice that the temperature is beginning to rise. So it started with 22, but then right now it's already at 28, and it continues rising. So if we were to put this sensor into some hot liquid or something hotter than my hand, we'll see the temperature rising up to the temperature of that liquid or device that is hot. So that's the end of this. We've managed to build our own basic IoT system. Go ahead and repeat this process until you understand, and make sure that everything goes well for you. Thanks, and see you in the next video.